Hello everyone and welcome to another episode on this very channel. In today's lesson, we want to look at formation of first order PDEs, how we can form first order PDEs from a given function. If you haven't subscribed to the channel, kindly hit on the subscribe button for me. So in the formation of first order PDEs from a given function, all what we are expected to do is to find out how these functions are related to their derivatives. How these functions are related to their derivatives. And in the formation of first order PDEs, they are as easy as ABCD. If and only if your algebra is very good. If you are algebraically good or your algebra is very strong, you can form as many PDEs as you want. So in the formation of first order PDEs, what we are to look for is to look for a PDE which contains this or a PDE which contains this. So this is first order partial differential equation. The same thing applies to this. This is a second order partial differential equation, and this is also a second order partial differential equation. You can also have this, or these are all second order partial differential equation. So in the formation of first order partial differential equation, we are going to look at something of this very form. So in the formation of first order partial differential equation from a given function, the first thing that we are going to do is to find the partial derivative of this function with respect to the independent variables within the function. So it means that we are going to differentiate the function with respect to x, then we differentiate the same function with respect to y. And that is going to give us our first two partial differential equation, the basic one or the fundamental one. So let's start. So our function is u is given as what? X squared y. So once you have your function, the next thing to do is to take the first partial derivative of this function with respect to x, and then we take the first partial derivative of this function with respect to y. Very easy. So we have u subset s, which means we are taking the first partial derivative of this function with respect to x. So in doing that, we are going to keep or hold all other variables in the function as a constant. Then we differentiate x squared with respect to what? X. So the all other variables in this function, we have y. So we are going to keep y as a constant. So we have y is a constant. Then we differentiate x squared with respect to what? X. When we differentiate x squared with respect to x, we are going to get what? 2x. So we have our first partial derivative of the function u with respect to x. We are going to get 2x and then y. Now with this, we can decide to bring all of them to the left hand side. So we are going to have ux minus 2xy is equal to 0. So these are first basic simple fundamental partial differential equation, first order partial differential equation, the very easiest one. Now let's move on to taking the first partial derivative of the function u with respect to y. It means we are going to keep all other variables in this function as a constant, then we differentiate y with respect to y. So all other variables in this function is what? X squared. So we have x squared, then we differentiate y with respect to y. That is going to give us what? 1. So we are having u of y is equal to what? X squared. Now once we have this, we can decide to bring what is on the right hand side to the left hand side. So we are going to have uy minus what? X squared is equal to 0. So we have another first order partial differential equation. Very easy and then simple. Let's look at another form. Now from the function u, so we have this is our first one, this is the second one. Let's look at the third one. we have to form how many? 4. So the third one, we are going to start from the function u is giving us what? S squared y. So from this function, we can decide to make y the subject. So if you make y the subject, it means we are going to divide here by s squared, so that this will cancel this. So we have our y is equal to what? U all over s squared. So from here, we can substitute y is equal to u all over s squared in place of y. So we are going to have from this one, we have u x minus 2x. Our y is given as what? U all over what? X squared is equal to 0. So when we do some small algebra, we are going to have this will cancel one of the x. We are left with 2u all over x is equal to what? 0. When we multiply through by x, we are going to get x ux minus 2u is equal to 0. So we have our first order partial differential equation. So this is the third one. So as I said, if your algebra is very good, you can form as many PDEs as you want. If your algebra is really good. Now from the same function which is given us, so we are going to make s squared the subject, and then we come and substitute in place of s squared here. So from here, to make s squared the subject, we are going to divide both sides by y, so that this y will cancel this y. So at the end, we have our s squared is equal to u all over what? Y. Then we come and substitute it into this. So we have uy minus x squared is equal to 0. Now wherever we see s squared, we are going to substitute this. So we have uy minus u all over y is equal to 0. Now let's multiply through by y. We are going to have y uy minus u is equal to 0. We have another first order differential equation. So we have the fourth one. Now let me give you one more. Now from this first one and then second one, we can equate them because we are saying that the whole of this is equal to 0 and the whole of this is equal to 0. So when we equate them, we can say that 2xy is equal to what? Uy minus s squared, because we are saying that the whole of this is equal to 0. This is also equal to 0. So we have 0, 0. So it means that this is equal to that. Now once we have this, we can decide to bring all of this to the left hand side. So we have ux minus uy minus 2xy plus s squared is equal to 0. So we have another first order partial differential equation. Now all of these PDEs, 1, 2, 3, 4, 5, the function u is a solution to all these PDEs. It means that this function will satisfy all these PDEs that we have formed from this function. Let's look at another example. So we have our example 2. We want to form 4 first order PDE from this function. First 4 order PDEs from this function. So from here, our function is giving us u is equal to sine xy. So once we have this, the next step is to take the first partial derivative of the function u with respect to x. So we have our u of x is equal to. So in taking the partial derivative of the function u with respect to x, we differentiate the outside, then we differentiate the inside with respect to x. When we differentiate sine xy, we are getting cos xy. Then we differentiate the inside is what? Xy. So we have del x. We differentiate the inside with respect to what? X. So with that, we are going to keep y as a constant. Then we differentiate x with respect to x, and that's going to give us what? 1. So we are going to have y cos xy. Now once we have this, we can decide to bring this to the left hand side so that we can equate all of them to 0. So you have ux minus y cos xy is equal to 0. So we have our first order partial differential equation. That is the first one. Then we move on to taking the first partial derivative of the function u with respect to y. So we are going to differentiate the outside. When we differentiate sine, we get what? Cos. Then we have xy. Then we differentiate the inside with respect to y. So we are going to differentiate the inside with respect to y. So we are going to keep the x as a constant. Then we differentiate y with respect to y, and that's going to give us what? 1. So we are going to have x cos xy. We can decide to bring the right hand side to the left hand side so that we equate all of them to 0. So we are going to have uy minus x cos what? Xy is equal to 0. So we have this. So we have our first order partial differential equation. Now from this, as I said, these are the basic ones, the fundamental ones that you can form. Now from these fundamental ones, you can form complex first order PDEs from them. So from here, let's divide this by that. So we are going to have ux is equal to y cos xy divided by this uy divided by x cos xy. So you can see that cos xy, you cancel cos xy. We are left with ux over uy is equal to y all over x. So from this, we can do some cross multiplication. This will multiply this. We are going to have x ux is equal to what? This will multiply this. We have y uy. So we can decide to bring this to the left hand side so that we have x ux minus y uy is equal to 0. So we have our third one. So this is a first order partial differential equation, and this is a solution to this PDE. Now let's look at another one. Now in trigonometry, we know that sine squared x plus cos squared x is equal to 1. If that is the case, then we can say that sine squared xy plus cos squared xy is equal to what? 1. So from here, you can decide to make cos squared xy the subject. So we have cos squared xy is equal to 1 minus sine squared xy. Now we are having y cos xy. Good. So from here, we can decide to take the square root on either side of the equation so that we are going to have cos xy is equal to the square root of 1 minus sine squared xy. Now from u, we know that u is equal to sine xy. We know that u is equal to what? Sine xy. But we're having square xy. So we can decide to square here and then square here so that it will be the same as this. So that in place of sine squared xy, we can substitute u. So from here, we know that cos xy is equal to root of 1 minus u. So from here, we know that ux is equal to y cos xy. So we know that ux is equal to y cos xy. Now we know that cos xy is the same as root of 1 minus u squared. So in place of that, we are going to write what? 1 minus u squared. So we have ux is equal to y. Then we have root of 1 minus what? U squared. Now you can decide to do away with the square root sign by squaring both sides of the equation. So we are going to have u squared x is equal to y squared 1 minus what? U squared. So let's expand the bracket. We're having u squared x is equal to y squared minus what? Y squared u squared. Let's bring all of them to the left hand side so that we can equate them to 0. So we have u squared x minus y squared plus y squared u squared is equal to 0. And this is also a first order partial differential equation. First order partial differential equation. So as I said, if your algebra is good, if you are algebraically you are good, you can form as many PDEs as you want. And all of these PDEs, the function u is a solution to all of these PDEs. The function u is a solution to this PDE, is also a solution to PDE. Let's look at the last example and then away bars. So we want to form 4 first order PDE from this function. The function is len xy. So we have our function which is given as len xy. Good. So as I said, the first thing that you are going to do is to find the first partial derivative of the function given with respect to x and then with respect to y. That is going to give you your 2 first order partial differential equation. So we are starting with respect to x. So this means we are going to differentiate len x, y with respect to x. So how do we differentiate a len function? How do we differentiate a len function? Let's say len x. How do we differentiate a len function? So to differentiate a len function, we have dx. To differentiate a len function, we differentiate the inside all over the inside. What is inside? We have x. Then we differentiate the inside with respect to x. That's going to give us what we want. So that is why when we differentiate len x, we are getting what? 1 over x. So what we are going to do here is we are going to differentiate the inside with respect to x all over the inside. So we are going to have all over the inside is what? Xy. Inside we are having xy. Then we differentiate the inside with respect to x. So it means we are going to keep y as a constant. Then we differentiate x with respect to x. That is going to give us what? 1. Good. So this means when we differentiate len xy with respect to x, we are getting y all over x, y. So you can see that this y will cancel this y. We are left with ux is equal to 1 all over x. So from here, we can do some cross multiplication. We are going to get x ux is equal to 1. Then we can decide to bring the 1 to the left hand side so that we get x ux minus 1 is equal to 0. So we have our first order PDE, our first one. Now once we are done, we move on to the partial derivative with respect to y. So we have uy. So with the same concept, we are going to differentiate the inside all over the inside. So all over the inside, we have x, y, x. So when we differentiate, when we take the partial derivative of the function u with respect to y, we are getting x all over x, y. So from here, we can see that this x will cancel this x. We are left with uy is equal to 1 all over y. So from here, we can do some cross multiplication. This will multiply this. So we have y uy is equal to 1. And we can write it as y uy minus 1 is equal to 0. So we have another one. So this is also a first order partial differential equation. Very good. Now from this basic simple first order PDE, we can form complex one. So we are saying that x ux minus 1 is equal to 0. And then we have y uy minus 1 is equal to 0. Is equal to 0 is equal to 0. Therefore, we can equate this to that to give us another PDE. So we are going to have x ux minus y is equal to what? Y uy minus 1. So let's bring all of them to the left hand side. So we are going to have x ux minus y uy. So this will cancel this, is equal to 0. So we have another first order partial differential equation. So we have 1, 2, 3. It's left with what? The last one. So let's look at the last one. So the last one, we are going to take it from the function. So we have the function u is equal to length xy. So when we take the e on both sides of the equation, we are going to have e power u is equal to this, will cancel this. We are left with what? Xy. So for me, we can decide to make y the subject by dividing both sides by x, both sides by x. This will cancel this. We have our y is equal to e power 2 all over what. So once we have this, we are going to pick this equation and then we substitute y in place of that. So we are going to pick that equation. So we have u y is equal to what? 1 all over y. And we are saying that y is equal to this. So we have uy is equal to 1 all over e power 2 all over x. So we have uy is equal to, when you do your algebra, you are going to get x all over e power u. And when you do your cross multiplication, you are going to get e power u uy is equal to x. Let's bring all of this to the left hand side. We have u power u uy minus x is equal to 0. We have our last one. Very, very easy and then simple. So as I said, formation of first order PDEs are very, very simple if your algebra is really strong. This brings us to the end of today's lesson. See you tomorrow. Bye bye.